Morning everybody. This is lesson 43, triangle congruence by ASA and AAS. The lesson today is the same idea of yesterday's lesson 4.2, but in 4.2 we were talking about the SSS and the SAS. Those are two postulates. We use them to prove that our two triangles are congruent, and we explained that the SSS is side, side, side. So if I'm able to find the three pairs of congruent statement related to the sides, this means our triangles are congruent. If I was able to find side and other side like this, and in another triangle this way, side and these two congruent, and he gave me that this angle equal this angle, so my angle is included in both triangles. So this means our pair of triangles is congruent. Now the objective of today's lesson is to prove that two triangles congruent by new postulate, which are ASA and AAS. I think you're able to guess what's the meaning of ASA and AAS. Warming up for this lesson was to revise the SSS and SAS and brainstorming the meaning of ASA. Yes, correct. It's angle, side angle, and in the middle of them, the side means the side is included between the angles, okay? And AAS, it's angle, angle, and the side is beside any of the two angles. By finishing those four postulates, you will be able to prove the congruence in any triangular pairs. Okay, let's talk about the first one. Here is the ASA. I have angle A congruent to angle D. Angle C congruent to angle F. The side should be in the middle or included between them. So I can say that AC, and this is the symbol of the line segment, is congruent to DF. Okay, so our triangles ABC and DEF are congruent. Let's see how the question can come as a problem, and we'll start our lesson. Here he's telling me using the ASA. So in the test, either he will tell you use any postulate to prove, or in the question, not in the test in general, any postulate from the four that you've learned to prove congruence. So you check which is possible to be proved, or he specify for you a way. If he specifies, you should find that the way that he told you. ASA, this means angle, and in the middle a side and angle. If I can only by looking, I'm seeing that here I have angle and side in the middle. This one, angle and side in the middle. The third one, I have angle and the side not in the middle, not included between them. So without solving, I can say that this pair is the congruent triangles pair. Why? Because angle U equals angle E, angle V equals or congruent to angle O, and the UV is congruent to OE. That's why our pair of triangles are, as written here, SUV is congruent to NEO. Okay, let's see the got it question. Here, only by looking at them, you need to look at a side included in between two angles. So if I have, by looking only, the first triangle, yes, it has an included side. H and G are marked, and the included one is HG, line segment. Here, this is not included because N and I are the congruent with the H and G, but the side which is marked in the middle of them, so I will not choose this. And the third one, I have the CA are marked and CA as a line segment is marked as well. So I can say that angle G is congruent to angle what? C. And angle A is congruent to angle H. And the line segment GH is congruent to CA. This is the line segment. So I can say that the triangle GH what? O is congruent to triangle CAT. And why I named it this way? Because what I know about the triangles, that GH are congruent to CA. So I'll write them and I'll put the third letter from each triangle. Now, here I have the problem solving. He's telling me the member of teen organization are building a golf course at the town. The design for this drawing, it should be having two congruent triangles. He asks me to prove that two triangles are congruent. I will look at them. It's very shown that AB is marked, the line segment AB is congruent to AD. Okay, angle A with one mark, congruent to angle D. And he told me that angle B is right angle and angle E is right angle as well, which both equals to 90. So they are congruent. So I can tell easily that the two triangles are congruent. The two triangles are congruent and the way of naming, take any side which is the side that it's congruent, start with AB and start with DE and put the third letter from your triangle. So it is ABC is congruent to DEF. Let's look at the drawing for the got it. 2. If I just look at the drawing, he told me that BA as a line segment is congruent to AE. And he told me that angle B equals angle E and congruent to angle E if both of them are 90 degrees right angles. This is as well given, and here given. The third angle, the second angle, which is CAB, is congruent to DAE. Okay, because he marked as well given. So I say that the triangle is congruent to the other triangle. How do I name it? I start with the BA that he gave to me and AE, which are congruent. I put the third letter in here, C, and I put the third letter in here, D. And I prove the congruence. Now, this is the first postulate. We've done it. The second one is AAS. AAS, this means that the side is not included between them. No, I should have two angles, and in one side of any of them, I should have this side. Let's look in here. I have given that the AC, this one, is congruent to DF. So then I had that angle A is congruent to angle D, and angle B is congruent to angle E. This means that the angle should be in one side. What does it mean, one side? Means when I have my angles should be connected to each other. Now, the side could be here FE with BC or FD with AC. Means the side should be in one or connected to one of the angles, but the angles should be connected to each other. I will not, yes, connected to each other. So DE and BA are the congruents. So either the side will be from the A side or the B side, from the E side or the D side. Let's look at the problem. He's telling me use the AAS to prove. What did he give me? He said angle M is congruent to angle K, and the WM, where's the WM here, is congruent to RK. Now, if the lines are perpendicular, then I will have a pair of alternate interior angles. Let's look at the angle MWR. MWR, which is this angle, and KRW. Aren't they alternate interior angles? Yes. If I have in here M and W are congruent to R and Q congruent. Did he give me any side? No, but I have the side in the middle, which is common in both the triangles. So I found the angle, an angle, and the side connected to one of the angles. In the second triangle, angle, and the side connected to the other triangle. So I was able to prove by AAS that the two triangles are congruent. Let's look in here at problem number 3. If you look at the drawing itself, the drawing in here is talking about two connected triangles, and these triangles are having a common side. But he added something in here which is given to you from before, but we need to re-explain or remind you with it. Angle S is congruent to angle Q. So this is the first angle. Angle S congruent to angle Q. Make sure that I'm looking at two angles and one side connected to any of them, from any side. Okay? Angle. And I have the PR as a side congruent to PR by the reflexive. This side in the middle. Okay? Now, I should have either the angles here in the top here, this angle to be congruent to this angle, or this angle to be congruent to this angle. The question told me that RP bisect SRQ. Where is SRQ? That is SRQ. This is the big angle, SRQ. Bisected, this means the first part, this is part number 1, or is congruent to this side. Okay, so I was able to find two angles connected to each other and what the side is in between them. So I will say that angle SRP congruent to angle QRP. What do I write? Definition of the bisect. Definition of the word bisect. So now I need to write that this is the first triangle congruent to the second triangle. Which side is the same? PR. So what do I say? What do I say in this? I will say that the triangle, here the S is with the Q, the R with the R, and the P with the P. So RB and RB, angle S with angle Q, and we proved the congruence. If I look in here, determining whether triangles are congruent. This is problem number 4. Use the diagram at the right. Which of the following statement best represent the triangles in here? Best represent the triangles in here. Okay? Now, if I look at those, I can see that I have, yes, the triangles are congruent by ASA, or no, if B and OT are not corresponding sides, C is C. Yes, the triangles are congruent by AAS, and no, angle B and angle U are not corresponding angles. He's telling you that the diagram shows that the two pairs of angles and one pair of sides are congruent, so you can say that AAS. However, the third pair of angles is congruent by the third angle theorem. So I was able to find that the third angle. To prove this triangle congruent, you need to use ASA or AAS. ASA or AAS. If I say ASA, this means I need to have two angles like here, and the mark of the side should be here. Is it the case? No, so I cannot say by ASA that the two angles are, the two triangles are congruent by ASA. Let's try the ASA. Let's try the ASA. Now, I have angle B congruent to angle U and angle I congruent to angle T. From the angle B, I have the mark, right? So from the same congruent angle, I should have the marked side, this one, okay? Because the side should be connected to the congruent angle. Means if I want to talk about angle B congruent to angle U, this means the BF should be congruent to UO. Is it congruent here to UO? No. So we can say that the answer is no. If B and OT are not the corresponding sides. So I want you to make solving such a question will make sure that yes, we want the side to be in any of the sides of the two angles. However, they should go from the same congruent angle. Let's make sure that this idea is clear to you, and we look at the got it number 4. Here we have two connected triangles, and those two triangles are marked. I will try to use, yes, he didn't tell me any of them. Are PAR and SIR congruent? Let's see. We'll start by angle A congruent to angle I. And angle IRS is congruent to PRA. Why? Because they are what? They are vertical. Now, the side in here is RS. RS is congruent to PR. Now, I need to make sure that my side is going from the same congruent angle. We said that PRA, so the first part of R, is congruent to the second part of R. And both lines are going from the congruent angle. So are they congruent? Yes. So the the A, and here congruent I, and R, and R, and the third is ARP, and here IRS, they both congruent. We're done this lesson. I want to make sure that you have understood the critical point in each one of the postulates. ASA, I need the two triangles, for example AS, to have the side in between them. If I will say that BD, and I will continue my triangle, doesn't matter. If I have that B equals A and S equals D, this means the two triangles are congruent. Or if I have the second way, which is AAS, I should have A and S and let's say B and D, okay? Let me just continue the triangle. If I have A is congruent to B and S is congruent to D, so either I will say that, let's say that this is SW and SK. Either I'll say that SW is congruent to DQ. Why? Because they both started from the same congruent angle, from S and D, they both congruent, so we give the side which is connected to them both. Or I will say that this side is the congruent side, which is DW is congruent to BQ because it is connected to the same congruent angles. The questions are very easy here. Try to do them by yourself and let me know if you have any problem. To save the time, I can answer any of your questions after looking at the lesson. Here in the second page is your homework. The number of the question is already written in the weekly plan. Please don't hesitate to tell me whenever you want. At the end of this lesson, we've learned 4 postulates to prove the congruence, which are ASA, AAS, and from the previous lesson, we said the SSS and SAS, okay? In the beginning, they look similar, but if you apply and sketch the 4 postulates, you will see that by solving, you will be able to recognize each of them.